Okay, okay. So now I'm going to continue with exponential equations. Trust me when I say very, very much important that we go through this type of problems because it's one of the things of which if you can master and fully understand them, trust me, doesn't matter which topic that you do in class, every calculation will make sense. So worry not in case if you are doing something else. I assume that it should be something that is easy to understand, easy to do. I'm just hoping that with the most difficult topics, I'll be able to then take you through so that when you get to those topics in class, at least you'll be in a better position to be able to ask some more relevant, confident questions. So just trust me when I say, if you can master these topics, you will never go wrong, especially the one that involves the exponents, application of the laws of the exponents. Not only that, but also the solving of the equations together with, it could be expansions or simplifications. So I've got just a few examples here that I would like to do, and then from there I will give you a lot of similar problems to solve. So, okay, let's say you are given 3 to the exponent of 2x, which is equated to 9. Very much important that you realize that the type of a math problem that you are dealing with here, it is an equation because you see an equal sign. Very, very much important on that part. And most importantly, you realize that you are having a base, which is a number, and then there on your exponent, you will therefore realize that that's where you are having your unknown, which means you might need to rewrite that 9 as a base to the exponent of something. So that one being 9, that base will definitely have to be the same as the base on the other side. That is why if you say 3 to the exponent of 2, it will definitely give you 9. So you had to rewrite it in that format so that the bases can be the same. And with regards to that, you end up having the basis falling away. Then you've got your 2x, which is equals to 2 there, and then you remove that 2 by dividing both sides by that, and then you've got your final answer, which is being equals to 1. And that should be the end of it. I hope that part makes sense. Okay, so now let's look at this next one. So let's say you are given that, maybe let's minus 4, then maybe let's equate that to 0. Yes. Let's equate it to 0. And then from there, what you should know is that anything to the exponent of 0 is equals to 1. So that means in this case where we are having that being equals to now we can write this as 2 to the exponent of 0. Why? Because if you punch on a calculator 2 to the exponent of 0, that's when it gives you 1. So we had to rewrite that one in that format. So obviously, bases are now the same. What you do, you equate the exponents, which means the bases, they disappear. Then you've got your x, you take this to the other side, it becomes positive 4, and that should be the end of it. I hope that part makes some sense. Okay. Okay, so now let's perhaps look at uh, this this one. Let us perhaps look at this one where, okay, let's see, what are we given there? Let's say we are given 5, where we multiply it by that to the that, and we equate this to that. So again, many ways in which you can work it out. Firstly, since you know that you've got a 1 there, it's still fine. You can still say, since you have the same basis, you add their exponents. If you don't want to do it that way, you can remove this 5. That means you will divide both sides by 5, whereby that cancels with that. Got 5 to the that. Then what will that be? Is it going to be 25? 125 divided by 5? Yes, it gives 25. And what we know is that 25, it is the same as 5 squared, which means now you are having x being equals to 2, because these bases are the same, and then they fall away. So that's how you would approach that one. Okay, so now we've got this one being 5 to the exponent of that, which is supposed to be equals to 1 over 25. Okay, so what you need to remember is that you are having 5 to the exponent of that, but obviously 25 is the same as 5 to the exponent of 2, that we remember. So now we might need to rewrite this as that being the base to the exponent of that, but let's rewrite it such that now we want the base to be 5. Obviously the exponent will change and become -2, because you move it from the denominator to the numerator. So that one, it is there as invisible 1. That's why I'm not writing it there. Now the bases are the same. What you do, you finally equate the exponents, and that's how you would work it out. Okay, maybe let me include the last type of a problem, and then from there we will see. Okay, this one, let's see. Okay, you are given 1 over 4, and then that is to the that, which is equals to 2. Okay, most importantly, we do know very well that 4 is the same as 2 to the that, and we are having that as x, and then we have 2 there. So you will still want to rewrite it such that this thing goes to the numerator. Because you have 1, no need to write it, but you will just change the exponent from being +2 to being -2, and that can be equated to 2. Then you take this, you multiply it by that. So that means you end up having 2 to the exponent of, what is that times that? Definitely it will be negative that, and then you have your 2 there. Obviously you have invisible 1 there. Now the bases are the same, and then what you can do, it is to equate the exponents, where now you will divide both sides by -2, so that that cancels with that. Then you've got your x, which is equals to -1 over 2. That should be the end of it. So now I think I think what I might need to do is just to give you enough problems to deal with, so that at least you will be able to verify if what I've just done, solving these problems, you can just apply on the problems that I'm going to give to you. So let's see how far you are going to go. But for now, I think I will just leave it here and say until we meet again. I hope